Hello everyone, my name is Matthew Williams, and today I will be telling you about the monitoring of the chemical composition and the evaporation rate of fluids in wet mount specimens. So, preserving specimens is very important to the field of zoology, as it allows for a consistent and easy way to obtain a source of reference, as well as be able to study specimens in a lab setting instead of out in the field. While some species, such as mammals and birds, can be easily preserved through removal of their skin and stuffing that skin, it's harder for soft tissue specimens such as amphibians, reptiles, fish, the like. These specimens must be kept in a constant wet environment with a preservative. This preservative could be ethanol, formalin, formaldehyde, isopropyl alcohol, and must be kept at a constant concentration in the solution in order to prevent decay of the specimens. Monitoring these concentrations is vital, but there aren't many easy ways to do so. Some ways include the use of density and calculating it out through that. Some use plastic wafers that will sink to the bottom and tell you once your concentration has passed the appropriate limit, but there isn't very good ways to apply this to other fields, such as ours, where our collection has been exposed, many of our specimens have been exposed to multiple preservative agents. This would throw off the density test as well as the pellet test. So we have sought to instead use gas chromatography as a method to learn the concentration of these solutions and monitor it that way. So to first see if this was possible, we used gas chromatography, a gas chromatography instrument, to obtain a reference curve of what different solutions and concentrations of isopropyl and water look like. So to do so, we created a couple different known concentrations of weight-to-weight ratio of water and isopropyl alcohol. And these included 30-70% water to isopropyl, 60-40 water isopropyl, 50-50 water to isopropyl, and 60-40 water isopropyl. And these are all run through the gas chromatography instrument you see in Figure 2 to obtain readings in their retention times as well as their heights. This would tell us how strong they are in making an appearance in the gas chromatography instrument, and especially the thermal conductivity of the instrument, as well as tell us what is the normal retention time of our two chemicals. But also, if we're going to apply this to our specimens, we need to find a way to properly select solutions. This is mostly due to the fact that these wet mount specimens will leach out lipids, proteins, and the like into solution. And we wanted to ensure that none of these large particulates would get into our gas chromatography instrument. So we also had developed a method to extract the solution, and we found through testing with a solution of albumin, which is just egg whites in heavy cream mixed in water, we found that the best method to extract a clear solution is through attaching a 0.2 micrometer filter to a 3 milliliter syringe and using that to extract from the solution. So once we knew that we now can extract solutions from the specimen in the wet mounts, and once we had our reference curve, we were able to then begin testing. So first, let's talk about the reference curve we found. We found, as you see in results, that the average of each of these tests showed a consistent rule, in a sense, with the water to isopropyl alcohol being off by simply a factor of 10% in each area curve. So if you see in table down below, for a water isopropyl alcohol 30-70, we found that the percent area of water was 21 and the percent area of isopropyl was 79. And to continue on this 40-60, it was then 33 and 67, and the 50-50, 41 and 59. and in 60/40 it was 55 and 45. So we were actually able to notice a pattern very early on that by simply subtracting 10 from the average percent area found in these gas chromatography readings, we were actually able to see the true concentration of the isopropyl in the solution. So we were able to conclude that we not only have a good method to find the concentration of isopropyl in our wet mount solutions, we are actually able to do so very easily with a very easy formula for our instrument. We do want to continue to go on and look into other ways to account for the formalin that could have been left behind in our specimens, as well as other things like that, but this is a good first step in that direction of being able to monitor our specimens much more closely.